All right. Today on The Explainer, we are diving into a topic where, fire, electricity, and the open ocean all collide. We're going to break down the science, the real world science of how you safely weld steel in what has to be one of the toughest environments imaginable, a ship out at sea. Okay, let's get into it. I mean, on the surface, it sounds pretty straightforward, right? Ships are made of steel. Steel breaks down. It needs repairs. So welding, that's just a basic part of keeping a ship running. But the thing is, what looks like a totally routine job is actually one of the absolute most dangerous tasks you can do on board. And yeah, that is the real question, isn't it? It's not just can you weld, but how do you possibly manage thousands of degrees of heat, a literal shower of sparks, all happening inside a ship that's basically built to haul flammable stuff across the ocean? I mean, the stakes here are just unbelievably high, because if you get this wrong, it's not just a stake, it's a catastrophe. So what is it that makes this specific job so incredibly dangerous? Let's really break down this pretty hazardous combination of factors. Okay, so the official industry term for this is hot work, and it's actually a really broad category. It covers any job that could create an ignition source. So we're not just talking about welding. It's also torch cutting, grinding, basically anything that can throw a spark. I mean, just stop and think about what a ship actually is. It's a giant floating steel box, and it's just packed to the gills with everything a fire absolutely loves. You've got fuel, you've got oil, paint, not to mention all these tiny confined spaces where flammable vapors can just sit and wait. The environment itself is it's completely hostile to the idea of hot work. So how in the world do crews even begin to manage this risk? Well, they do it by breaking it down. They focus on three core threats. Think of them like three different enemies. And by targeting each one individually, they can build up this really robust, layered defense. So let's start with the big one, the most obvious one. Threat number one, and it's the one we all think of first, fire and explosion. We're talking about sparks, tiny little pieces of hot metal that can fly more than 10 meters. And then there's the molten slag, the waste metal that can drip right through a crack in the deck and start a fire in the room below without anyone even knowing. It's such a sneaky threat because the danger can pop up way, way far from where you're actually working. So how do you combat that? You do it with layers of protection. First, you create a sterile zone. The rule is you have to clear everything that could burn for 11 nanometers, that's about 35 feet, in every direction. Now, if there's something you just can't move, you cover it up with special fire-resistant blankets. Next, you have to test the air itself for invisible dangers like flammable gas. And then finally, you post a guard, a dedicated fire watch, and their only job is to scan for any sign of a fire. All right, the second big threat is electric shock. To melt steel, arc welding uses a massive amount of electrical current. Now, think about doing that on a ship. It's often damp, sometimes it's outright wet, and the entire structure is made of metal that conducts electricity beautifully. So the risk of a fatal shock, it's not just there, it's magnified a lot. Okay, so tackling this one is a mix of good procedure and smart tech. First off, every single piece of gear, especially the cables, has to be inspected before you even start. Modern welding machines have this great safety feature called a voltage reduction device, or VRD, and that keeps the voltage at a much safer level when you're not actively welding. But here's the absolute number one rule, the one you can never, ever break. You never use the ship's hull as the electrical ground or return path. Why? Because that path is totally unpredictable. You risk sending stray currents all over the place, which can destroy equipment or worse, cause a deadly shock. And the final threat, this is the one that's a bit more insidious. It's the stuff you can't always see or feel right away. That welding arc is unbelievably bright. It pumps out intense UV and infrared radiation that'll give you a nasty condition called air eye. It's like a sunburn on your eyeball, and it can give you severe skin burns. But even worse, maybe, are the fumes. The fumes from welding are officially classified as a Group 1 carcinogen. To put that in perspective, that's the same category as asbestos. So again, the protection here is all about layers. The first line of defense is engineering. You capture those toxic fumes right where they're being made using local exhaust ventilation. The second layer is personal. The welder absolutely has to wear a respirator. And then to protect everybody else in the area from that radiation, the whole work site gets shielded with these heavy, opaque welding curtains. Okay, so we've laid out the threats, right? Fire, shock, fumes. But the real secret to staying safe, it isn't just about reacting to those things. It's all about the plan. The most important work on a job like this happens way, way before a single spark even flies. And right at the very heart of this whole safety system is one rule that is completely non-negotiable. Absolutely no hot work starts without a signed hot work permit. Period. And this isn't just some piece of bureaucratic paperwork. Think of it more like a formal contract. It's a guarantee that every single risk has been thought about, identified, and controlled before the job ever starts. It all kicks off with what they call the pre-work stage. That permit forces you to do a really detailed risk assessment. You have to ask the hard questions. What could possibly go wrong here? What's on the other side of that wall? Is every piece of equipment inspected and ready? Is the PPE, the personal protective equipment, the right kind? And is it in bridge shape? Only when you can answer yes to every single one of those questions can you even start to prepare the work area. Then you get to the execution phase, and this is governed by its own set of strict rules. First, there's the two-person rule. Nobody, and I mean nobody, ever does hot work alone. It is always a team, the welder and their partner, the firewatch. Second, no shortcuts. You use all the equipment exactly how the manufacturer says to use it. And this is crucial. If you stop working for any reason, even just for a quick break, the power source gets shut off instantly. So you've got this great plan, right? The plans are useless without people to execute them. And those people need to two absolutely critical things: the right personal armor to keep them safe, and partner with a watchful eye to keep the whole ship safe. And that personal armor, the PPE, it's a full head-to-toe system. For your eyes and face, you have an auto-D darkening helmet that reacts faster than you can blink to protect you from the arc's flash. For your body, a fire-retardant suit, usually with heavy leather aprons to literally deflect hot sparks and slag. And for your hands, you need dry insulated gloves that can protect you from incredible heat and electricity. You see how each piece is a specific defense against a specific threat. But, when you look at all the safety systems, the permits, the tech, the PPE, the official guidelines are really clear on one thing. The single most critical safety component isn't a machine. It's not a gadget. It's a person. It's the fire watch. And their only purpose is to watch for fire. They are a dedicated and very active member of the team. And their job doesn't just end when a welder packs up. A tiny stray spark can hide somewhere and just smolder, for a long, long time before it finally bursts into a real fire. And that's exactly why the fire watch has to stay put, monitoring the entire area for at least 60 minutes after the last spark flies. The danger it lingers. Ultimately, all of these rules, all this gear, all these procedures, they all point to one final and probably most critical piece of the puzzle. It's not really about just following a checklist. It's about building a culture of constant vigilance. I mean, just think about what this quote is really saying. The Firewatch isn't some passive bystander. They're the first responder. Their role is every bit as important as the person holding the welding torch. And that really hammers home this core idea of partnership. That real safety depends on every single member of the team. So when it all comes down to it, the permits, the checklists, the helmets, they're all just tools. The real goal, the thing that actually guarantees safety out there on the water, is having a shared culture where every crew member feels personally responsible for their own safety and for the safety of their teammates. And that leaves us with one final thought. In any high stakes environment, really, not just on a ship, but anywhere, can safety ever really be just about ticking boxes on a form? Or is true, genuine safety something that can only ever happen when it becomes a deeply held, shared responsibility for everyone involved?